In this video, we'll use an extended tile sequence and a factor rectangle to find the factored form and the x-intercepts for a quadratic function. This is the case where added x-strip 0 pairs are needed. Our question is, given the pictured extended sequence of tile figures, sketch the x figure and use a factor rectangle to factor the function and to find the factored form of the function and the x-intercepts for the graph of this sequence. We'll start by looping the figures to find the x figure. This is not a very complicated sequence. Each figure has a constant 9 red tiles. That's the value -9. And each figure has the figure number squared. So you can see that our function here called t of x is equal to x squared minus 9. And our x figure will be a black x square and 9 red tiles as illustrated here. To create a factor rectangle, we must arrange the pieces in a rectangle in a way that the edge dimensions make sense. In the x figure, there are 9 red tiles and no plus or minus x strips. We will have to add 0 pairs of white and opposite white x strips to create a factor rectangle. 9 red tiles can be 3 by 3 array or a 1 by 9 array. And those are both illustrated here. To fill in the empty areas, so regions 2 here and regions 3 here, for the 1 by 9 array of red tiles, we would need 9 plus or minus x strips on one side and 1 plus or minus x strip in the other. Neither 1 x strip plus 9 negative x strips nor 9 x strips and 1 negative x strip are sets of 0 pairs. So you can't use the 1 by 9 array. On the other hand, for the 3 by 3 array of red tiles, we can use 3 x strips on one side and 3 negative x strips on the other. Since 3 times -3 is -9, and that's 3 sets of 0 pairs, we're all set. Notice that the location of the positive x strips and negative x strips could be reversed here. So you can see we have 3 and 3, so 3 0 pairs. To determine our factored form and x-intercepts, we must measure our edge dimensions. On the left side, we have x plus 3. We have black edge pieces here. And on the top, we have x minus 3. We have red edge pieces here. So t of x is x squared minus 9 is equal to x plus 3 times quantity x minus 3. That's our factored form. When we set that equal to 0, we find that x is -3 or 3. So our x-intercepts are -3, 0 and 3, 0. Let's check our work. For our x figure, each figure has 9 red tiles and a black square with dimensions the size of the figure number. Yes, this matches our sequence. That checks. We can also see that figure -3 has 9 red and 9 black tiles for a net value of 0. -3, 0 is an x-intercept. You can see figure -3. We also can see that figure 3 has 9 red and 9 black tiles, again for a net value of 0. So this checks that 3, 0 is an x-intercept. To check our factor rectangle, we need to make sure that the edge dimensions result in the correct regions. When we look at our factor rectangle, we have x times x, x squared, region 1 checks. We have x times -3, -3x, region 2 checks. We have +3 times x, 3x, and +3 times -3, -9, region 4 checks. Our answer is we have the x figure for the sequence, 9 red tiles and 1 black x square. We have our factor rectangle and factored form. T of x equals x plus 3 times x minus 3. And we have our two x-intercepts, negative 3, 0, and 3, 0.